After StructureMaster is installed, two new icons appear. The first one is QL. QL means Quick Look. Click to open the Quick Look. The first option of QL is the continuous beam program. Let's solve a sample beam problem using beam calculation. This sample beam is made of tube steel 8 by 6 by 3/8, length is 300 inch. Left end fixed, right end a roller, an additional roller support and a center hinge in between. The loadings are, 2 concentrated load of -2.0 and 10 kip. 1 linearly varied distributed load. Its intensity varied from -0.5 to 0.7 kip per inch. Let's solve this problem. Click Beam Calculation. This is the continuous beam calculation. At the top, buttons Open, Save, Save as Manage Beam Calculation Files. Clear Entries resets the input. Refresh Graphic refresh the display of the latest beam configurations. Below these buttons, there is a text box of message. Beam program checks your input. If there is any error, it is shown here. Next is the graphic area. It displays either beam geometry or loading. This area is updated whenever Refresh Graphic button is pressed. Below the graphic area, there are 3 tab pages. The first one is beam geometry, the second, loadings, and the last is to organize the final report. This is the geometry tab page. Let's follow the order of the green numbers. Number 1 is to define the length of the beam, length unit, and material property. This beam is 300 inches long. Click MATLAB, select a 36, click Set Material to set the material property. Number 2 is to define supports. Here, you may choose either of the beam ends to be fixed or roller support. For our case, left end is fixed, and the right end is a roller. Next is to define additional roller support, if any. Here, we have a roller support at location 180 inches. Next is to define center hinge, if any. For our case, at location 100 inches, we have a center hinge. Number 3 is to define section properties. This beam is made of tube steel 8 by 6 by March 8 inch. Check Uniform Section box and click Seconds Lib button. Select HSS 8x6x3/8 from AISC library. Then, click Set IX Value button. Section property is now defined. For beam of variable sections, check the variable section box instead. Here, you may specify 4 different IX values through the length of the beam. Click Uniform Section. Click Refresh Graphic to view the updated geometry, length, supports, material and section properties, and their respective locations are displayed. We are done with beam geometry. Next, click tab number 2 Apply Loading. Number 1, for the loadings, select kip as the force unit of the applied load. All loadings are vertically applied. Next, for the report, select kip and inch as the output units of the final report. These two selections of units offer the flexibility to apply loading and presenting the result in different units. Number 2, specify concentrated force. Here, we can specify up to 8 sets of concentrated load and moments on the beam. For the example, we have 2 concentrated loads. At the location 45 inch, we have -2 kips load. At location 270 inch, we have a 10 kip load. Number 3, specify distributed force. Here, we can specify up to 6 linearly varied loads on the beam. Here we have 1 linearly varied loading. At location 80 inch, its intensity is -0.5 kips per inch. At location 210 inch, its intensity is 0.7 kips per inch. The intensity varies linearly between these two locations. Number 4, specify vertical enforced displacement. For each of the supports, you can also specify enforced support displacement. Loading is fully specified. Click Refresh Graphic to view the loadings. Concentrated and distributed loads and their respective locations are all displayed. Now, turn to page 3, Result reporting. Right after moving to page 3, beam calculation presents result graphically. At the top is the geometry, in the middle is the loading, at the bottom, there are 3 curves of different colors. The red dotted curve is the deflection, the green one is the shear diagram, and the blue one is the moment diagram. Right below the curves, the maximum and minimum values of the deflection, shear and moment are displayed with their locations in the corresponding color. These 3 diagrams gives you a quick look at the results of the beam calculation. Close this graphic window, and back to the result reporting page. The final report consists of the following: summary, graphics, and details. Let's go through the process of organizing the final report. Use the number 1 button to select the reports to be included in the final report. There are 3 reports to be selected: summary, graphic, and detail. The default is the summary and graphic reports. Click View Final Report to view this default selection. It is concise, less than 2 pages long, but include all the summary of the analysis for you to make decision. Click the red X button at the top to close it. If you want to include the details to support the summary and graphics, check the checkbox of details. Then, click the number 3 View Final Report button. Here is the report. It is much longer. Scroll down and every detail of the analysis is presented. Number 2, customize the graphics to your liking. Up to 3 diagrams can be selected. The default graphical presentation is the one displayed right now. Let's uncheck the first one, geometry, then, click the View Selected Graphics button. Now, only 2 diagrams is included, loading and results. Click the black X button located at the top right corner to close it. During this stage, you may click this View Final Report button anytime, to see how it looks. If you are satisfied, click the File button at the top left corner, to specify a file name, and save the report to a RTF file. Then, click the X button to close it. Back to the final report page, you may click the button Save or Save As to save this beam to a file so that you can work on it later. This problem is saved to file demobeam.beam. We are done. Close the continuous beam program.